assume all inputs are available, both complemented and uncomplemented. So don't worry about the complement of, but we have a function which is g equals wx plus wz plus w bar x bar plus w bar y bar and z bar. And it looks like this was simplified for us, so don't worry about simplifying this. It's already done. They give us both expression. They give us, this is sum of product. They also give us the product of sum. And the product of sum for this, it's w bar plus x plus z. Again, it was simplified. They did their Boolean algebra for us. Times w plus x bar plus y bar times w plus x bar plus z bar. This is product of sum. And here are the question. Question A. Implement, that means build it, using NAND gates only. And it says of any size. So don't worry if it's 3 input, 4 input, don't worry about them. They want us to implement that using NAND gates only, NAND. So think of NAND as what? And with the not. And. Well, if you use the question, do you use the top or the bottom equation? Look at the top. It has how many ands in it? Lots of them. It's easy to convert the and to NAND. So we're trying to decide which one should I use. You want to use the top one for this, because what you have is an AND gate with WX. It says assume both inputs are there. That means them and their complement. WZ, W bar, X bar, they're saying assume the complements available, so you don't have to make a NOT gate for them. And the last one is what? W bar, Y bar, Z bar. And the result, all of them are what? Or together? That's my design. But now they're saying, wait a minute, you can't use AND and OR, you have to use NAND. So what do we do? Yep, double complement. See, double complement every one of them. We double complement each one of them. So now these are NAND, and what about an OR gate with both inputs or all inputs are complemented? That's also a NAND gate. So now you have and that's your design. Because an OR gate with all the inputs are complemented, that's the same as NAND gate. Now let's remember this design here. We have to deal with that later and see. Second part to this question. Implement using NOR gates only. Same question. Implement using NOR gates only of any size. So the size is not an issue. NOR gate, that means you're looking for ORs. So we take the bottom one. We got W1, we got X, and we got Z. They're all going to be ORed together. ORed, not NORed. We have W, X bar, Y bar, ORed together. And the last one we have W, X bar, Z bar, all ORed together. And the result at the end is what? Is that ANDed together? That's what I have. Look at my expression, that's what I have. But again, they want us to use NOR gates, not OR and AND. They want NOR only. Double complement each one. Double complement each one. Double complement this one. So now you have W bar X Z with a NOR gate going through it. We have W X bar Y bar with the NOR gate. And the last NOR gate is what? W X bar Z bar NOR gate. And all the result now are what? What's an AND gate with all the inputs complemented? A NOR gate.
No, it's all right to change the format, right?
To what do you mean change the format to what?
Well, if you're adding a NOR gate at the end, that would be pretty much adding, correct?
Well, no, because it says use using NOR gates only. So you don't have a choice.
Okay.
You have to put that NOR gate
So
there.
it doesn't matter.
So now we just designed the whole thing. So when they said NOR, I went to product of sum. When they said NAND, I went to sum product. Last piece to that problem, I want you to design that using two input NAND gates. Two input NAND. Two input NAND. They don't want to use 4 input and 3 input NAND. So part C, same problem. Implement using only 2 input NAND gates. When we did it in part A, let me just put the circuit from part A, then we'll deal with that. From part A, we had this. So I'm good so far. These are 2 input NAND gates. I'm making progress. So far, it's still good. 2 input NAND gates. Here's where the problem comes in. Now, that's a 3 input. I can't use that one. And at the end, we had a NAND gate here, 4 input. So if they want to use 2 input, I said, okay, I'm good here. I'm good here. I'm good here. I'm not good here, and I'm not good here. And the question, can I make a 3-input NAND gate out of 2-input NAND gate?
Probably can. By connecting them together, no?
Let's see. Good, we have a sheet of paper still. Some of you probably thinking this way. Go on, let's look at that. Let's see, I'm going to build a 3-input AND gate. If I have A, B, C, so there's my output. I want the NAND gate A, B, C with the NOT over it. That's a NAND gate. So my options are what? 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Next one, 4 zeros and 4 ones. An AND gate, it says, okay, it's a complement of AND. So an AND gate, the only way to have a 1 if all inputs are 1. So down here, if there was an AND gate, that would be a 1. But we're going to complement that, that will be what? 0, and the rest of them are 1. That's what it's supposed to be. Some of you are probably thinking, if I want to make a 3-input NAND gate, we'll just use A, B, and C. Why can I take 2 of them? I think that's what some of you were thinking. Take the result and AND it with, or NAND it with the 3rd one. Would that do it?
No, but that would cancel out, no? A, B.
Well, let's see. Let's find out what A, B, NAND. A, B, NAND gate between A and B. So A and B is going to have a value 0, 0, 0, NAND 0 is what? 1, 1, 1, 1, 1, 1, 0, 0. Take that, C, NAND it with C. What will happen? 0 or 1? 0. Complement 0 and 1. 0. Complement that. 1. 1 and 1. 0. I mean 1 and 1 is 1. Complement that. 0. 0 and 1. 0. Complement that. That's a 1. 1 and 1. That'll be 1, complement, that's 0. That's a 1. That's a 0. That's a 1. And that's a 1. That doesn't look like this gate. Not the same. Okay, so what are we going to do then?
Maybe would you be able to add C to A and B? As an
Add C?
Add another wire to B and
Add C, you mean OR gate here? Is that what you're saying?
we're not allowed to use OR gates, correct? It's only
Well, you can start with now and see if you can fix it later. Notice that's a problem here. Yes,
Can you use a NAND gate as a NOT gate?
you can use an AND gate as a NOT gate, sure.
What if you did A, B, and then C bar,
A, B, and C bar.
and you did all that NAND together?
A, B, and C bar. Like this.
And then NAND.
And NAND them. Let's see what A, B, and C bar first. A, B, and C bar, that's a 0 anyway. That's a 0. 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 And now with the last two, A, B, and C bar, that's a 1. And that's a 0. Oh, that's a 0, I'm sorry. That's a 0, A, B, and C bar. A, B, and C bar, that'll be what?
I think you got it right.
That was a 1, I think, the last one, right?
Yeah.
So
And this is 0.
And
And now you say you want to do what? AND it?
work, yeah, that'll work.
That one, do it.
Yeah.
So now if you complement that, almost, you want to match it with that one. Well, here's a suggestion. That AND gate. Leave that one here. That AND gate, or NAND gate, I'm sorry. Isn't that an AND gate with the NOT at the end? And the NOT is this. Right? That's an AND gate with the NOT at the end of it. And I can use a 2-input NAND gate to make the NOT. I need 3-input AND gate, we'll call them A, B, and C. You can make this as what? A and B. With an AND gate, that's okay. The result is ANDed with what?
Thank you.
The result is ANDed with C. So I can now, and here's that little knot here. So now this one here, that's an AND. If I want to make it an AND, I can do this, right? That doesn't change it. You agree with that? If I double complement that, I can do that. Well, let's see what we have so far. Remember, this is really a NAND gate. I can even erase it here. That's an AND. Now slide this one back. If I slide this one back, it's going to make it look like what? It's going to look like this. An AND gate. If you take that AND gate back. Now I got a 2-input AND, except I got to deal with that little guy. So now I can take that gate here, go, okay, I got it. I got A, B. It's an AND gate. But now I'm going to take the result and do what with it? Complement that, because I don't want to change that to anything. And this is C. See, instead of AND, I broke it down. I said this AND gate here, this one I'm looking at here, it's really A, B, ANDed together with the result being ANDed with C. That's good. The problem with that, I can't use the AND. So I try to put them here so I can't use it. But if I double complement this and double complement that, I'm still okay. That makes this one an AND. But to double complement this, I'm actually going to take it and put in another NOT gate, which is this one right there.
Well, don't they have to be 2-input, or you could just grab that one?
1, 2, 1, 2. You see attached together, 2 input.
Oh,
1, 2.
okay, I see what you mean.
Yep. So that's what I did with that 3 input AND gate. And you can do the same thing with the 4 input AND gate. When you have 4 input AND gate like this, don't worry about the NAND. Treat them as an AND for now. This is the NAND. So to make it an AND, there's your NAND now, right? Just put it away. You can take this, change it to 2 input AND gates. The result is what? AND it together, and there's your NOT gate. This gate is this one. This is this one.
So for this one, they really didn't care if we, as long as we were using.
Yep, NAND
It
gate
doesn't matter
on.
if we used AND gate.
Yep. So this is actually, when you look at this, it's, oh, this is what I got. A, B, and C, D, and if you slide this gate back, if you slide it back, that's an AND. So I managed to get this one as NAND, but these two are ANDs. So what do I do here? NAND, and put a NOT gate here. NAND, put a NOT gate there.
So when you have a complement, it cancels out, correct?
Double complement cancels.
So that.
So that makes that an AND, and to make this, you make it a 2 input. That's your NOT gate.
So it
Right
changes
there.
it back to an AND.
Yep. So notice how I played with the math algebra to change everything to 2 input NAND.
Together, then it gets doubled
Yep.
to go through another
Yep.
one.
So my final answer for this, it would look like this. They're saying assume all these inputs and their complements are available, so I don't have to worry about them. That's all NAND. Now we have a 3 input here. So the 3 input, I'm going to replace it with this circuit. This one, which is what? W bar, Y bar. I'll take the first 2. I'm going to AND them together. I'm going to take the result, feed it through a NOT gate, which is I'm going to make it out of a NAND gate, going into another NAND gate, and attach to its Z bar. That's the 3 input. Now these 4 inputs going to go into the AND gate, and the equivalent of that AND gate is going to be this. So here we go. I'm going to try to make now a 4 input NAND gate. There's a 2 input NAND gate. Take the result, flip it through a NOT gate, which is a 2 input NAND gate, and take the result at the end and NAND it. And this, I'm going to do the same thing. Through a NAND gate, that's right here. Then I'm going to take the result through a NOT gate, which I'm going to make it out of a NAND gate. And now I just design my whole circuit using NAND gates only.